Well, now we're doing question 3, and we're given that y equals ax squared plus bx plus c, and we're given the points 1, 2, -2, -7, and 2, -3. Now the first points in first coordinate in each point is an x-coordinate. The second coordinate is the y-coordinate. So we're going to translate that into this form. In other words, we're going to solve for a, b, and c by letting, in the first equation, x equals 1. So we get a, and 1 squared is 1, plus b, and b times 1 is b, and plus c equals, and the y-coordinate is 2. Now we'll do that all over again. So in this case, x is -2. So when we square -2, we get 4. So that's 4a. And x is -2, so that'll be -2b. And we get a c, and the y-coordinate is -7. Now let's do it again. In this case, x is 2, so we get 4a, because 2 squared is 4, plus 2b, plus c, and the y-coordinate is -3. So there's the system we have to solve for a, b, and c. So let's write our augmented matrix. That is, write the coefficients on a, b, and c. 1, 1, and 2. And we have a 4, a -2, a 1, and a -7, a 4, a 2, a 1, and a -3. Those are the coefficients on a, b, and c. And now, the first row never changes. 1, 1, and 2. In fact, let me give myself a little more room there. 1, 1, and 2. And we want to eliminate that 4, get a 0 there. We also want to get a 0 there. So we'll take row 2 minus 4 times row 1 will replace row 2. And we'll do the same thing with row 3. So row 3 minus 4 times row 1 will replace row 3. So let's write row 2 down, and that is 4, -2, 1, -7, and multiply row 1 by -4. So -4, -4, -4, and 2 times -4 is -8. Add them up. There's our 0. We get a -6 here, a -3, and a -15. Okay, 0, -6, -3, and -15. Let's take row 3, write it down. 4, 2, 1, -3, and add it to, multiply row 1 by -4, and add it to row 3. So there's our 0. We get a -2, a -3, and a -11. So 0, -2, -3, and -11. Now, let's leave row 1 intact, always. But let's multiply row 2 by negative 1/3. So negative 1/3 row 2 will replace row 2. In doing that, we get 0, 2, 1, and 5. Row 3 will remain intact. 0, negative 2, negative 3, negative 11. So there's our matrix. Now we need to get a 0 in this position. So row 1 will remain the same. Row 2 will remain the same. But row 3 is what's to be modified. And so we're just going to take row 2 plus row 3 and replace row 3 with that sum. So let's take row 2, which is 2, 1, 5, and to it add row 3, which is negative 2, negative 3, negative 11, and add them up, and there's our 0. We get a negative 2 and a negative 6. 0, negative 2, negative, I beg your pardon, I need a 0 right here, excuse me. 0, negative 2, negative 6. Now we need a 1 in this position, so one more stroke of business and we'll have it. So there's row 1. Row 2 doesn't change, 2, 1, 5. But we're going to multiply row 3 by negative 1/2. So negative 1/2 row 3 will replace row 3, and we get 0, 0, 1, and 3. So now what we know is this, that this implies that z equals 3. So taking what we know, 2 is a coefficient on y, so 2y plus 1z. Well, z is 3 plus 3 equals 5. Now let's solve for y, so we get 2y. Subtracting 3 from both sides equals 2, so dividing through by 2, y must equal 1. So y equals 1. Now, let's take row 1 and this, oh, excuse me, I'm talking about x, y, and z. I beg your pardon. I should be talking about a, b, and c. A, b, and c. So c equals 3. B equals 1. B, B, and B. And finally, we've got A, 1A, so A plus 1B, but B is 1, plus 1Z, but Z, or 1C, but C is 3, and that equals 2. So in other words, A plus 4 equals 2. So subtracting 4 from both sides, we get A equals minus 2. So our ordered triple then is negative 2. Well, our A, B, and C's are A is negative 2, B is 1, C is 3. And if you go back to the original equation, and so we're claiming A equals negative 2, B equals 1, C equals 3, and install those values in for A, B, and C, you'll have true statements. And we're done.